Hi everyone, my name is Pradyumn Kejriwal and today we'll discuss the solution to the 14th problem from the CP-31 sheet by TLE Eliminators under the rating of 14 pitfalls. So let's begin. As you can see, I have my problem right here and I can open this. Okay, so the problem is called Weird Sum. Igor has a table of size n by m with lines numbered from 1 to m and columns numbered from 1 to m. Each cell has a color that can be represented as an integer from 1 to 10 to the power 5. Let us denote the cell that lies in the intersection of the rth row and the cth column as r, c. We define the Manhattan distance between two cells r1 c1 and r2 c2 as the length of a shortest path between them. Various consecutive cells in the path must have a common side. The path can go through cells of any color. For example, in the table 3, 3 of 3 by 4, thus the distance between 1, 2 and 3, 3 is 3. The paths is like 1, 2 to 2, 2 to 2, 3 to 3, 3. Igor decided to calculate the sum of Manhattan distances between each pair of cells of the same color. Help him to calculate this sum. Okay. So what they are saying is they have defined like they have a grid. Okay. They have a grid like this. Let's say we have a 3 by 3. Alright. So they have defined something called Manhattan distance. And some of you might have heard of it also. Okay. So like between the cell R1 C1, R1 C1 and R2 C2, they have defined the distance as the minimum number of moves that you have to make. Like for example, if you want to move from here to here, you have to first go down one. So 1 and 2 and then 3. So this is the shortest path. So if we in general see that what's the formula of this, then I think it is pretty famous that if this is R1 C1 and this is R2 C2, then of course shortest path would be like from this and then like this, right? So this distance is basically mod of R2 minus R1, right? And this distance is just mod of C2 minus C1. So essentially the distance between R1 C1 and R2 C2 just comes out to be R1 minus R2 mod of R1 minus R2 plus mod of C1 minus, right? So this is your distance formula and like this is very famous also. So yeah, what they want us to do is that they have colored this grid into many colors. Okay, so let's say there are 3 colors for now. So they have colored it like this. Maybe these are green, then these are yellow or something. So what they have want us to do is they want us to find the distance between every pair of the cells having the same color. We want to find the sum of distances. Okay. So for example, we have let's say a grid which is of 2 by 3 size. Let's say this is a grid 2 by 3, and let's say this is color 1 and color 1, and this is color 2, this is color 3 and 3. So we have to find the sum of Manhattan distances of all pair of cells having same color. Okay. Just pardon the handwriting. I think you get it. Like I am speaking also. So we have to find out the distance, sum of distances. So in this case, like we have 3 ones, right? So we can have this pair, we can have this pair, and we can have this pair. So the distance between this is for this pair is just 1, right? So we have 1. Okay. We have 1 plus. Then for this pair also distance is 1. And then for this pair, distance is 2. Then we have only a single 2. So we have no pairs. And we have 2 3s. So like only a single pair. Okay. So this pair, the distance is 1. So the answer is 5, right? And similarly, you can find out the answer for the sample as well. For the sample, you can find the answer, or you can read this as well. So they have explained it. And for these other ones, they are pretty large. So if you want to find out, you can do that. Okay. So yeah, that's it all. You have been given this grid, and you have to find out the sum of ratios of all pairs having same color. And the constraints here are that n into m should be r is less than equal to 10,000 or 1 million or not 1 lakh. Okay, 10 to the power 5. Your n into m uh, is less than equal to 10 to the power 5. So since we are able to do approximately 10 to the power 8 operations per second, then so we are allowed like O of n into m, right? But what we cannot do is O of n into m whole square or something, right? So we cannot do that. So now you can pause the video and try to solve this by yourself. Alright, so I am assuming that you have tried to solve the problem by yourself and now you want a solution. Alright. So first of all, the thing that we can notice is that we want the sum of all pairs for all the colors, right? So we can find out the answer for each color individually. Okay, like here we had these cells, right? So here we had like 3 whites, 3 yellow cells, 3 red cells, and 3 green cells. So we want to find the sum of all colors. So we can just find out the answer for this yellow color first, the sum of all pairs having this yellow color. Then we can find sum of all pairs having this red color, and then we can find sum of all pairs having this green color, and we can add them up, right? So basically, we can find the sum of all pairs, all colors. I mean, all colors individually, right? So we have this thing sorted. So we basically need to calculate every color's answer. So let us see how to calculate the answer for a particular color. Okay. So let's say you have like 3 cells marked red, right? So like you have this one, uh, you have this red cell, and this red cell. Somehow this, okay, you have these 3 red cells, and you want to find out the sum of all pairs, right? So let's say that you have 3 cells colored red. Their coordinates are x1, x1, y1, x1, y1, x2, y2, and x3, y3, right? So what you will do is you will find out the sum for all the pairs. So let us write that, like this sum distance of this pair is what? For this pair, the distance is x1 minus x2 plus y1 minus y2 with absolute value, of course. So this is the first pair. Then for second pair, like let's say you take this pair. Okay. So you have mod of x1 minus x3 plus mod of y1 minus y3, right? And then for a third pair, you have, like for this pair, you will write mod of x2 minus x3 plus mod of y2 minus y3. Okay. So now actually you can rewrite this as something else. Like you can simply group all the x terms together. Just group these terms together, right? So just keep them in one bracket. See, this is a sum of 6 terms, right? This whole thing is a sum of 6 terms. 1, 2, 3, 4, 5, and 6, right? So just keep these x terms in one group or in one bracket, and just keep these y terms in another bracket, right? And you can calculate them separately and finally just add them up, right? So basically we can see that x and y are independent. Our x and y are independent. Okay. So we can calculate them independently and then add. So how do we actually calculate that? So basically what we want to calculate here is mod of, let's say there are only three vertices having a particular color. So we have mod of x1 minus x2 plus mod of x2 minus x3 plus mod of x1 minus x. Now this is not something like x1, x2, x2, x3, x3, x1. No, it is like all pairs. Like if you had four, like let's say there are four vertices x1, x2, x3, x4, x1, x2, x3, and x4. Then you would have had mod of x1 minus x2 plus mod of x1 minus x3 plus mod of x1 minus x4. Like you want all the pairs, right? So plus, like you have x1, x2, x1, x3, x1, x4. Then you would have x2, x3, right? Then you have x2, x4, x2 minus x4. And then finally you have x3, x4. So for four vertices, you have six pairs, right? So you want to calculate the sum for this. But how would you do it efficiently? Like one way is just to iterate over all the pairs, right? Like just do for I from, like for I from 1 to k and from j from I plus 1 to k. You can just add up the absolute value of xi minus xj, right? But this will take O of k square obviously, and that will not pass as we saw. O of n into m will not pass. So instead, like okay, sorry, here k means that the number of vertices having that particular color. So in this case, k is equal to 4, right? So yeah, O of k square won't work. So what can you do actually? Actually, what you can actually do is, sorry for saying the word actually too many times. Anyways, so what you can simply observe is that what is a minus b come all? Like just look at this value for now. Just look at it carefully and think about it. What is it actually? Like it is defined as, basically if you have a greater than equal to b, then the mod of a minus b is the same as a minus. For example, if you have 5 minus 3, then the mod of 5 minus 3 is mod of 2, which is just 2. So it's just 5 minus 3 itself. And like if you have b greater than a, if you have b greater than equal to a, then this value is equal to b minus a, right? So that means if we have two values a and b, and we are taking the mod of their difference, then that means one of the values will be positive. Like in this case, let's say a is bigger than b. So a has been positive. A has like opened with positive sign, and b we have with negative sign, right? So whenever we have two numbers with this minus sign here and the absolute value, we will have one number with positive sign, and that will be the bigger number of the two. So whatever is the bigger number of the two, that will have positive sign. Okay. So let's say here we have something. So we want to calculate this thing, right? So I'll copy this to explain you. So I'll copy it and paste it here. So what I'm saying is, see, let's say you just sort these values. Okay. Like let's just assume that x1 is greater than x2, is greater than x3, so greater than x4. Now first thing to notice is that, see, if you look at x1, so in how many pairs does x1 come? Just tell me that. Like here we have k is equal to 4, right? Here we had k equal to 4. So in how many pairs does x1 come? Like this is 1 pair, 2 pair, 3 pair, 4 pair, 5 pair, 6 pair. So out of 6 pairs, in how many does x1 come? In 3, right? Like in this one, and this one. So in general, if you have like k pairs, x1 will come in k minus 1 pairs, right? That makes sense because x1 has to come with every other number. Like every number has to come with every other number. So basically x1 will come with k minus 1 pairs, in k minus 1 pairs I mean. because there are k minus 1 other numbers. Like x2, x3 and x4, there are 3 other numbers. So x1 has to come with them, right? And since I assumed that this x1 is the greatest, right? So that what does that mean? That means that in all of these 3 absolute values terms, x1 will come out as positive. Like I can write this as plus x1 minus x2. I can write this one as plus x1 minus x. Like I can just solve the mod. I have simplified this modulus, right? So since I know that x1 is the greatest, x1 is greater than x2 as well, x3 as well, and x4 as well. So therefore, in all of these 3 terms, the x1 will come out as positive term. So like if I want to open the absolute value, it will come out as positive, right? So basically, in general, if I say that in the final expression, I will have x1 3 times. Like I have 3 times x1 in my final answer. Because in no other terms, x1 comes. Like only here in these 3 terms, x1 comes. And in all of these 3 terms, x1 is positive. So we will have 3x1. Then we have x2, second largest, right? So x2 also comes in 3 pairs. x2 comes with x1 also. That is this pair right here. Then it comes with x3 also. And then it comes with x4 also. So x1, x3 and x4. So x2 comes with all of these 3 terms. But the thing is that since x2 is the second one in line, right? So since x1 is greater than x2, x1 is greater than x2. So that means that when x2 is with x1, then it will be negative, right? Like x2 is negative right here in this case. But in both of these cases, this and this, since x2 is the bigger one, it will be opened in positive. Okay. So plus x2 minus x4 plus x2 minus x3, right? So basically we have one negative and we have 2 positive, right? So as the net, essentially we have 1 positive, like 2 minus 1. We have 1 positive x2. So we do plus x2. Now similarly, I'll just go quickly over this. x3 is with x1, x2 and x4. When it comes with x1 and x2, it will be negative. And with x4, it will be positive. So basically it is 1 negative. Like it is minus 1. So minus x3 and x4. x4 whenever it comes, it will be negative only because it is the smallest. So in all the 3 brackets, it is the negative. So it is minus 3x4. Right. So this is your final answer. Like you can simply do this. You can simply solve this in O of k. Right. So in general, if I say, this was just to like explain to you, but in general, if I have k terms, right? If I have k terms, which says that x1 is greater than equal to x2, greater than equal to x3, and so on up to xk. So if I have k terms in a particular color, then I can say that the sum, like the sum which I want, that is this sum, I is less than j, absolute value of xi minus xj. Basically, sum of all pairs, absolute value. Since I want this sum, this will just be equal to, if we just try to get the contribution, like x1 के साथ क्या आएगा? What will come outside x1? So x1 will come in k minus 1 terms, right? And in all of them, it will be positive. So it will be k minus 1 into x1. Then this x2 will also come in k minus 1 terms. But in one term, like with x1, it will be negative. So in one term, it will be negative. And in the rest, k minus 2 terms, it will be positive. So essentially, like this is one negative and k minus 2 positive. So we have basically k minus 3 negative, essentially, right? So we have k minus 3 into x2. And if you keep doing this for all the other terms, you will notice that there's k minus 1, k minus 3, k minus 5, and so on. K minus 5 into x3, and so on, up to the last term, xk into something like, I think 1 minus k into xk. Okay. So you will find that this is the case, and you can simply just run a for loop. Like you can just run a for loop of k size to find out this sum. right? In the code, I'll tell you how I have implemented this. Like, I have made an index from which goes I equal to 1 to k, or other 0 to k minus 1, because I have 0 indexing in there, and another variable which starts from k minus 1 and decrements itself minus 2. Like, first it is k minus 1, then it becomes k minus 3, and then up to, like, it decrements minus 2 every time. So, and then, like, I just do sum plus equals j into a of I, where I is going from 0 to k minus 1 and j is going from k minus 1, and it is like doing minus 2 every time, right? So that's what you can do. So I'll just show the code also. Like, okay, now using this, you can solve for a particular color. Like, you can do the same thing for y as well. The same thing that you have done for x, you can do for y as well. And so you will get a particular color answer. And for all the colors, then you can add that. Like, you can add that up and you will get the final answer, right? So I'll just show the code. So yeah, I have first taken the input in this A array, 2D array, and into m size, right? And also I have made it like 0 indexed. The colors were from 1 to 10 to the power 5. I made them 0 to 10 to the power 5 minus. Okay. And then I have like arranged these x and y. So like for every color, this basically this x of I just stores all of the x coordinates having the color I. Okay. And same for y. So what I'm doing is I am iterating over the entire matrix, and x of aij dot pushback I. That is for current like cell I comma j. The color is a of ij, right? So I am just pushing back my x coordinate into that particular vector, x of aij, right? So essentially what I have done is I have made a vector of vector, like, which contains color wise data. So for the 0th color, which x's are there, for first color, which x's are there, and so on. And same for y. And then I have this function called calculate sum of all pairs, and I call this for every x and every y, right? And I add that up, and I do that for every color, right? And this function, I'll just show you how it calculates. So first we just reverse sort this, sort greater than greater and greater. So I just reverse sorted this, that like we had the reverse sorted thing right here, x1, x2, x3 greater than, right? And then indent equal to v dot size, or like we had k as v dot size, and long sum equal to 0. For int I equal to 0, j equal to n minus 1. So I have two variables. First to iterate through the array, and second is the multiplier. The multiplier, which is like k minus 1 first, then k minus 3, then k, and so on. So this j starts with k minus 1. So for int I equal to 0, I less than n, I plus plus, and also this j minus equals to 2. And in the sum, I just add j into v of I, right? And also I took it in long because it can overflow. So sum plus equals to j into v of I, and I return the sum. So this will calculate the this sum in O of n log n time. N log n goes sorting. So this will take O of n log n time, right? So yeah, this can calculate the sum of all pairs in O of n log n time. And like, since we are calculating the sum for all the colors, we can simply notice that the TC of this is nm into log n. Like, why is that so? Actually, it is because, like, I'll just give an example. Okay, so we have like this thing right here, where we have 3 yellows, 3 reds, and 3 greens. So to calculate for the yellow, it will take 3 into log 3 time. Then for this red, it will again take 3 log 3 time. And for this green also, it will take 3 log 3 time. So in total, we have 9 log 3 time, which is even less than 9 log 9. Like, basically, when we add it all up, like when we add the k for all the colors, we get n into it, right? Like, what is K essentially? K is just the number of cells with a particular color. So if we just add that up for all the colors, of course we get the total number of cells, right? So if we just find the total TC, it is just the total number of cells. We can have a log factor also because of sorting. So total number of cells nm into log factor of nm, right? That is the TC. And the space complexity is just of n into m because we are storing this x and y. And this will take of n into m space, right? So I hope you all got this. Thanks for watching.